I'll make this one quick. Thank you all for joining us again. I'd like to introduce Chaitra Ramarao, who will be going through our cross-data center active-active cluster-to-cluster replication. So take it away, Chaitra. Thank you.
Thanks, Perry. Welcome, everyone. Thanks for joining us here today once again to learn more about our replication technology. So a lot of what we are talking about today is going to be, in general, the kind of challenges the businesses are facing and why replication is a solution to these challenges and how we as technologists at Couchbase are striving to accomplish them. So as we all know, replication in typical layman's terms is nothing but storing copies of the same data in multiple computers or multiple places. And what is astonishing or what is really appealing is that that very same concept of like replication, just storing data in multiple places, has today been the building block for the defining technology of distributed systems for enhanced performance, fault tolerance, and high availability. Okay, so out of this session, if there is just 3 things that I want you all to take away, it would be understanding the kind of problems that we are solving. Why exactly are we building what we are building, and what are the problems that we are solving using this? And secondly, I want you all to know like why is XDCR, as Perry already introduced it, or our cross data center technology is actually uniquely positioned to solve these challenges. And thirdly, how easy it is to actually do this. We'll talk about the big challenges, and then you'll actually see how easy it has been made to actually solve these technologies using XDCR. These are the major 3 things that I want you all to take away. But if you are learning anything more than that, I'm happy to be there for that. And to do that, we'll get started with the challenges on what are the big challenges that we are facing today, and introduce XDCR. Then we'll go through a demo so that you can all see, you can all believe what you see and see how much of what I'm claiming is true. And then we can take a look at a couple of customer case studies where you can understand how our customers are actually using this technology to solve their problems. So before I get started, a quick show of hands. How many of you are like completely new to cross data center replication? You don't know what is Couchbase, you don't know what it is? Just one? Okay, so are all the rest of the folks power users of Couchbase or power users of XDCR? Okay, this is going to be interesting. Okay, so beginning with the challenges. Global high availability. It's a no-brainer in today's on-demand technology and in the on-demand economy especially, where we need the high availability irrespective of where the users are located. And we really need the applications to be responsive at millisecond or sub-millisecond level with almost no downtime. And initially, globalization was just a niche concept, but today, as globalization from a phenomenon, it has expanded to what we call the enterprise standards. It has become more and more challenging for each of us, for the technologists to step up and build the technology to actually accomplish this problem. So what we need to remember here, so I think there was this article where Amazon gave out some numbers like slowing down Amazon.com by a second would actually result in $1.6 billion in sales for them per year. And Google countered it by saying that slowing down their search by about 4/10 of a second would indeed result in loss of 8 million searches per day. So this is the quality of the responsiveness and the distribution and the high availability that we are challenged with for providing. So what I want to convey with this is we are challenged to provide the same responsiveness irrespective. Markets are expanding, enterprises are expanding their footprint across the globe for different challenges, and for different use cases, like maybe for cost efficiency, maybe for new market expansion, for better revenue generation. But to meet those needs, we need to build a technology to address them. And the second challenge is catastrophic disasters. I think this is a concept which we all know what happened just a few days ago in Hong Kong with the typhoon, or what's happening in Florence with the hurricane. So basically, failures can happen at any level, basically, be it a single node or be it an entire data center. But the challenge is when these failures happen at these catastrophic levels, so when it surfaces at the data center or regional level, we need systems. Enterprise will be at a huge risk of data loss, and we need systems which can provide a steadfast solution to have minimal impact on business continuity. And this is where, again, the need arises for us to build the systems which acts as like a life insurance when something happens. Okay, so now shifting gears a little bit. We all want to switch to cloud. Okay, why do you want to, if I ask you, like, why would you want to switch to cloud? You all might give me, like, tens of reasons saying better agility, better flexibility, I don't want any operations overhead, I want cost efficiency, all good. Cloud is the name of the game. But what if a service provider which you have chosen has rolled out a major product update which does not work for your organization anymore? Or let's say doomsday, the cloud vendor themselves go out of business. So what are the challenges that you face then? So I think when and let's take a look at the consumer market for a moment. Like, we as consumers consume so many cloud services. Like, we use Flickr for sharing pictures, we use Gmail for email, we use Slack for chat, we use Twitter for tweeting, we use Facebook for social. But we do all this without any complexity of moving from one vendor to another, just based on like our use cases. Then why don't we provide the customers with the same flexibility? Our customers are enterprise, so why don't we provide the enterprises who are using our product the same flexibility to migrate between different clouds, or at least assure them that, okay, if something does not work well with the provider whom you have opted, you don't really have to fret. Your technology works well elsewhere. You have that flexibility, you have the freedom to make the choice, and we will give you a product that will work with no impact on your performance irrespective of where you do. So that's one challenge where we want to solve, where we want products which are like interoperable between the clouds, be it an on-prem cluster, be it a public cloud, be it a private cloud, or a combination of those. We want to build a technology that is robust enough to work with no impact to the business. This leads me right to the next challenge, which is about, okay, your technology works on all these platforms, but how do I really migrate data between these clouds? And what is the kind of complexities that's involved? So when we know that one of the biggest challenges to cloud adoption is what we call the complexities involved in migration between one cloud to another. So because of the migration challenges that is involved, the enterprises are mostly, logged in, or like they are just forced to stay with what you have primarily opted. So these are the challenges: global high availability, and cloud data migration, cloud interoperability, and having our life insurance. So what is our solution to these problems? I would like to introduce, okay, our solution to these problems, Couchbase's response or solution to these problems is our cross data center replication technology. I would like to introduce that with this animation, which I believe rightly projects what it's meant to do. So cross data center replication, as it's indicated in this figure, is all about migrating. It's a very useful technology which is helpful to migrate data from one Couchbase cluster to another. You can have those two Couchbase cluster either in the same data center, or you can have it in different data center, which is typically different data center. That's why we have named it cross data center. And you can have those data centers literally across the globe, wherever you need. Now let me introduce you give you a little bit more about like what has made XDCR what it is today. So one of the most distinguishing features of XDCR is that XDCR is able to operate at the speed of network and memory, which make so why and to learn a little bit more about like what makes it highly performant, I'll give you an overview of XDCR's architecture. So the data from our application server flows through our client SDKs, and it is written to our built-in memory. And once it is written to the built-in memory, depending upon the ask, it is either replicated from memory to memory for inter-cluster replication, or it is persisted for the disk and for the intra-cluster replications. For the replication queue, it enters, and the replication happens between memory to memory. And it is this memory-to-memory replication which makes XDCR highly performant and highly efficient. And another point I want to highlight is that the performance of XDCR is something that is tunable, where you can always, depending upon the number of nodes in the source cluster and in the target cluster, you as users always have the ability to tune the number of nodes, and then say, okay, and then choose, like, depending upon your bandwidth, what's the performance of XDCR that you would need. What you want to take away from this is XDCR is a really powerful solution, which is like highly performant and memory-to-memory replication. And you, as customers, have the flexibility to tune this replication to your need. Okay, so I spoke about high data availability as one of the biggest threatening challenges, where like what are some of the big, and also shared with you some numbers on like how some of our big customers or like big five are losing like billions of revenues if we are not performing at the level expected. So how is Couchbase equipped to solve this problem? So Couchbase provides unidirectional and bidirectional replication. So by unidirectional replication, I mean you can replicate data from the source cluster to the target cluster. It is a one-way replication. Whatever, maybe your writes are being taken in one cluster, and you would want to migrate the reads to both the clusters. So you can always set up an XDCR unidirectional replication to migrate to have the users do reads from both and writes from one. Or you can set up a bidirectional replication. Like, let's say the application which you're dealing with cannot handle any delay, and you need a system where you, like, because even when you say, I set up a unidirectional replication, there is all this replication, whatever I'm talking about, happens asynchronously. So there is going to be some level of delay depending upon where you have replaced your cluster. So if you cannot really afford the delay, your application cannot afford the delay, and you want to say, no, I want to really see the writes from wherever it's happening. So then you have the ability to set up bidirectional replication, where you can replicate from the source to target and from the target to source, and the replication happens between both of them, and you can always ensure the reads and writes are served instantly and from the primary location. And what expands to that is the topology that we support. So as we were seeing in that use case of like high data availability, we want a technology which is like really robust so that we can deploy clusters anywhere in the world. And like we were giving examples, let's say our website goes viral overnight. We want the ability to scale them independently depending upon the need. And to support that, XDCR provides complex topology. We actually support master-master replication, first of all, and you can really do any sort of topology like chain, star, mesh, ring, you name it, and XDCR is positioned to handle those. And I mentioned briefly about master-to-master replication, which is a follow-up on like the XDCR being a replication between two independent clusters. It is almost a peer-to-peer architecture where you can scale both the clusters independently, depending upon your need, wherever you have really exercise them, and you don't have any dependency on the other cluster. It's not like literally like a master slave, but it is an architecture where independently you can add nodes to each of those, and XDCR takes care of all the topology changes that happens. And like I mentioned in the architecture slides, the way XDCR is built ground up also makes this highly performant. So because of its like really low latency and the ability to like span across complex topologies, and the replication capability of unidirectional or bidirectional makes XDCR uniquely applicable to solve the high data availability challenges that most of the users would have. Another point that I have mentioned briefly, which I would expand upon, is our support for active-active. So, okay. So by active-active, what we mean is we have two clusters, irrespective of where they are located, and both are equipped to take the reads and writes, and then replicate the reads and writes to one another. We have several customers who are using this, which I would take some examples of it later in the session. But XDCR is uniquely positioned to perform this bidirectional active-active replication, where each of the clusters can actually take both reads and writes because of the way it has been built up as an independent cluster and its ability to scale, and which also provides high throughput. And when we talk about active-active replication, what comes to your mind definitely is like, okay, what in case of conflicts? Yes, when a mutation happens on whenever there are mutations on like multiple servers, and before they synchronize, there is a chance for the conflicts to occur. And for resolving those conflicts, we provide two conflict resolution mechanisms. One is the most update wins, and the other one is the last write wins. So for most update wins type of conflict resolution, what happens is on the document, each time a revision is made on the document, there is a count of like the number of revisions on that document, which we call as rev ID. And based on the number of revisions on the document, the one document with the most updates wins the conflict. And the other replication, conflict resolution that we support is called last write wins, where, so what you see from the previous conflict resolution method is that the most update need not necessarily reflect the most recent update. It might in most of the cases, but it's not necessary that the same document which has maximum number of writes actually is reflective of the last write. So that's where we go to last write wins, which we also call it as timestamp based conflict resolution. So in this mode of conflict resolution, the document with the latest timestamp of the mutation wins the conflict. Okay, so I was just mentioning about like how catastrophic failures can just hit us anytime, and we also saw, we're recently experiencing a couple of them right on the corner. So how is XDCR equipped to solve this challenge? Yes, at any point in time, you can use unidirectional replication from XDCR and maintain an active cluster and your passive cluster. And whenever there is any of such disasters, you can just point your replication to your cluster from the active to your passive cluster, and you will be all set with barely any impact to your business continuity. Okay, so if you have been here for the cloud data platform session, one thing you would have learned, or if you're all like none of you, most of like when I checked with you, most of you are like power users of Couchbase and XDCR, so you know this, that Couchbase works across all these platforms. Like you take the public clouds, you take private clouds, you take on-prem, you take anything, you name it, and Couchbase works. But how do you think Couchbase works on all these platforms? It is, of course, the technology is cloud native. Apart from that, like if you want to switch from one platform to another, you do that using XDCR. So XDCR is your solution for like cloud interoperability, where you can migrate your data from one Couchbase cluster to another, irrespective of where they are and whichever platform you choose. This solves both the problem of cloud interoperability as well as the data migration between clouds. Okay, so now I have claimed a lot of things, and maybe I thought it's worthwhile for us to just go through this and see what it is. So I've set up two Couchbase clusters here. First one, as you can see, it is on Azure. And this is on Amazon AWS. So this is a cluster that I've set up with 4 nodes. And this is a cluster that I've set up with 2 nodes. And I've also loaded them with some sample data to witness replication. Here I've loaded them with a sample data called travel sample. And on this, I've actually loaded it with a data called beer sample. Okay, so now let's come down. and set up replication. So for replication, you need to add a remote cluster. So let's call this cluster connect. And the IP would be instead of connect, let me call this, this is what I'm setting, remote cluster from Azure to AWS. So this will be more intuitive if I call it AWS. Okay, let's do this. I'll come back to something else. Okay. So once you have added a remote cluster for replication, you then have the option to add replication. Before that, let me go to this and create another sample bucket where we want to replicate the data. And let me call this demo. So now I add replication, select from travel sample, select as AWS. And now we say, okay, save this. And then you can see the status as starting up. And now we say replicating. Now go back to the AWS server and you see that it is replicated. The data from travel sample is replicated in literally few clicks. And this is how easy it is to use XDCR to migrate data between clouds or to replication between any data centers wherever you are. Just a few clicks. If you would like, we can also do bidirectional replication where we can set it up from Azure to AWS, but there are a few other things which I thought I would go over, which would be helpful. When you add remote cluster, you have the ability, let's say I select enable secure replication, we have the support for like literally with non-secure replication, what is called is with username and password, which I just executed for the ease of showcasing this feature. And then we do support the other security parameters like half mode, what we call as where your password is secured using the hashing with Scramsha. And then you have the option to choose the full TLS encryption where you will be encrypted using X509 client certificate authentication. And let me see something else. And another thing is that we support filtering. So this is another useful use case when we think about that high availability use cases where the customers would want to, like data locality and high availability use cases, where the customers would want to replicate data only a subset of data to their respective clusters and not really the entire data. So for all these use cases, we support key-based filtering as of now, and we would be expanding this filtering to a value-based filtering as well. And using key-based filtering, you can build expressions using regular expressions, and based on that, you can filter the documents. And then let me show you some other advanced settings that we have. We spoke a lot about like the flexibility with like how many source nodes source nozzles you can choose, how many target nozzles you can choose. So we also introduced the ability for, we introduced this feature called compression recently in our previous release where you have by auto, we do choose compressions for, you can choose to compress your replication for network bandwidth conservation. And you can tune this replication performance based on the number of source nozzles or target nozzles that you have. I think these are the most important features of XDCR that I wanted to indicate. Is there anything else? Security dashboard. So I can do something where, let me show you something else. I'm gonna try this, but I'm just hoping it'll work. Don't catch me if it doesn't. So what I just wanted to show you here was like the entire cluster which I've chosen, the replication is consistent across. So be it this node where we actually replicated it and where you see the buckets, or this node. So this particular cluster is a cluster with 4 nodes. So when you perform replication, it is consistently divided across all the nodes. So in whichever, so I took one example initially and then I demonstrated it with the other node, and you can see that it's consistent across. So what we learned was like, it was really easy to transfer the data from AWS to Azure or vice versa. You can set up unidirectional replication or bidirectional replication, and you can independently scale. That's why I had chosen a cluster initially on Azure with 2 nodes and on AWS with like 4 nodes to show that how XDCR actually takes care of this topology mapping. Do you want me to show anything else? Is there something that you are looking for in this demo to see from whatever I have shown you? I mean, some things you can, you'll either have to debug through the logs or some other, I will come back to it during the question answer session. If there's something that you want me to show, I'll show you right now and come back to it. Is there something else you want to show? I can answer the questions once we wrap up. You want to see bidirectional replication? Yeah. So maybe I'll try replicating back from AWS to Azure then. We set up, I think, from Azure to AWS, right? XDCR. So I set it up. See, this is an Azure account. So I've set it up from Azure to AWS. We can do the same. We'll go back to an AWS node, and we'll say add remote cluster. Cluster name, what do I call this? I'll call this Azure. And IP or host name of Azure. So I just added an Azure cluster on AWS environment. So now let me first go create another bucket, maybe in it. So you see this is replicating now. And if you go back to your Azure cluster and see, you see these documents replicated. You can verify it, like beer sample, for example, here has 7303 documents, and you see that same in the Azure cluster where it is 7303 documents. So now they are replicating bidirectionally from Azure to AWS and AWS to Azure on like typically the hybrid cloud environment. Okay, so now switching gears, we'll go back to our slides. So I have some customer case studies which I would like to go through to just to substantiate what we have stated here, and where you can see what are the kind of deployments the customers are having using XDCR. So one of this, what I'm showcasing here is the customer here is one of the brand names in travel and hospitality industry. So they use XDCR for their airline inventory management. So they're using XDCR on using this topology where for data locality. So they have all their reads and writes happening in their central cluster, probably in Europe. And they have set up, and they wanted to move away from their monolithic data center design to a more dispersed architecture for better data locality and performance. So they have deployed clusters across the globe, and they have set up unidirectional replication between each of these clusters with key-based filtering. So they are filtering based on the kind of airlines, like you might be a United user, you might be an American user, you might be an Emirates user. So depending upon the which airlines or like which countries that you exist in, they want to keep the user data as close to the customer as possible for reducing the latency. And for that, they have used XDCR with the star topology, where the reads and writes are happening in one active cluster in, let's say, London, and then the reads are happening for that from various other clusters across the globe. And to filter the subsets, they have been using key-based filtering. So this is another customer who, for their business continuity application, so they use XDCR for a number of their applications, and for each of their applications, they have an active cluster and a passive cluster. So and this is what they are using as their disaster recovery plan. So wherever they have an active cluster, they also maintain a passive cluster. So in case something goes wrong, they can quickly switch to the passive cluster and use them. So they also maintain unidirectional replication with the active passive topology for their disaster recovery use case. Yeah, so this is one of our customers who is using XDCR for their session management on high availability. They have they use bidirectional XDCR in a ring topology for their application, where the reads and writes are happening on each of these clusters, and they are replicating the data from one to another. And the conflict resolution method they are using for this is called last write wins, is what I explained a while ago. And they have really high write availability, so for which they also want the writes to go to different clusters. And again, for maintaining high availability and performance, they are using it in a bidirectional ring topology kind of deployment. Apart from this, these were the major three things that I had picked, but apart from this, there are customers who are using XDCR for performing upgrades, like when they are going from an on-prem environment, let's say today, and they want to go to AWS, they upgrade using XDCR. And there are customers who are using this for, again, cloud data migration. So there have been a number of peripheral use cases which are like tangential probably to what its primary use cases, which our customers are also using for. And XDCR has been able to serve all the challenges that we have been mentioning a while ago quite efficiently. Yeah. Mm-hmm. If it is only unidirectional. It has to be. I mean, if you're set up a ring topology, then you want consistency across the cluster, right? Yeah. Yes. Of course. Once you have written it, and once we have maintained that we have replicated it to all the three clusters, we would stop it. Otherwise, we would just be. Yes. Yes. Otherwise, we would be doing the same thing all over again. Yeah. This was what I had in store with the session, but if you have anything else that you want me to address or want me to showcase, we can definitely have. And if you like whatever is happening here, we have XDCR's engineering team here. Give them a good round of applause, because all the magic you see is built by them. Can you please stand up? You, John, and Neil for the four. John, you should. Yeah. Yes, please.
Chaitra, can you talk about the replication queue, how big is it, and if let's say I wanted to have a DR data center, should not be up and running all the time. Let's say I wanted to just, bring it online for some time and then shut it down fully for the cost purpose. So let's say
So you don't
window that it passes, it has to re-replicate the entire data, whether it has a timestamp based, so that
yeah.
copy the modified document, something like that.
Yeah, we have something called checkpoints, which remembers sequence numbers and checkpoints. It's an implementation detail, but we're using which we remember what was the previous document which was replicated and to where. So when your replication, you pause the replication. Oh, I think I forgot to mention that. So you can also pause and resume the replication at your convenience. And let's say in whatever a replication fails, it will because of some network inconsistencies, XDCR by default will retry until the replication is successful. But if you want to pause it, you can always pause it, and you can resume it from the place where you left off.
Yeah, but how big is that queue? How long it can pause? I mean, does it has a kind of a circular buffer, or is it able to, when I pause it, then all the incoming write performance will suffer on the primary side?
No, I mean, why would the write performance suffer if you are like stopping it from where it was and the replications are adding? When you reinvigorate that replication from whatever data is available, depending upon the queue, for the initial sync, the bandwidth available, first it will do an initial sync with all the replications, and then it will continue with the rest. I don't know, is that what you're asking, or? Push-based replication.
Sorry, my only question is when the replication queue becomes full, what will happen after that?
It doesn't.
So
There is no
It doesn't, yeah.
That's basically an internal checkpoint. We use it to restore databases all the time, and it will actually checkpoint from the beginning of time, which is pretty awesome. So we've had our databases connected for 2 weeks at a time. We've connected them, and they both come up the same. Not a problem.
So I think a lot of your question goes back to that architecture of like how we are extracting from the data surface, where are we like checkpointing, and why would we hold that queue, and where would we replicate? But yeah.
But when you take a real life scenario, I'm doing 1 million writes per second and then it's checkpointing every second.
You can choose the checkpointing interval as well.
Now we have basically two levels here. So you look at a lot of the architecture we talk about memory function. So a lot of the basically between 1 million write per second. Those write will first go through its memory. And then that's the first thing that the XCL will pick up and replicate. So that's why we have memory to memory. But if that queue, you can say, hey, that queue is actually really, like you said, important.
Yeah, remote data center is down for an hour.
They spill over to the disk. And when you resume, we're not doing everything from the memory anymore. We basically start doing it from the disk.
Okay, so
Until that is catch up, then we'll go back to
okay, then I can understand.
this one, and then you.
Hi, I have a question around active-active in XDCR when you set up, when conflict resolution, and when you use time-based for resolution, right? So first question is, how do you make sure that timestamps are coordinated,
Yeah.
right? The NTP
Yeah.
errors and stuff.
We use HLC, which is called a hybrid logical clock, which is like a combination of physical and logical clock. And like if I have to say, I mean, what is the logical clock in the simplest terms, like a counter which keeps track of the processes which has been updated and the messages that is sent. So based on a combination of these two, what is called the hybrid logical clock, we try to maintain that timestamp synchronization across the geographically distributed cluster. And we actually copy the, John, please correct me if I'm wrong, but we also copy the timestamps across the node so that it remains consistent. But if you want to add on, please.
So this is a separate activity from conflict resolution to keep the clocks in sync.
It is separate. So you do need to entity and synchronize. But what you say that with the hybrid clock in the sense that, because even with entity, you know that there's all clock has some issues, right? For example, you could the clock will go back sometimes, right? But you don't have synchronizations. So what the HLC does is that you ensure that the timestamp is monotonic. So that you need, this is a very important feature, right? One of the core principles of doing complex solution is that every timestamp or every division number has to be monotonic, so that we can reliably check what is the latest, what's the latest changes. So HLC is actually ensure that the timestamp you have is monotonic. But you do actually want to ensure that, you know, to get some good accuracy for your complex solution, you want to make sure that you use NTP to keep, you know, your cluster clock be close to, you know, to the same.
Okay, thanks for that. The follow-up on that is it possible under a conflict situation, can I get access to all the documents that was part of the conflict, even though you resolve it?
The logging of the conflicts, we don't have that today, but I also heard another customer requesting for it, so we'll consider it. Yeah.
And maybe we'll brainstorm with eventing services and brainstorm whether
We can use eventing for pulling it up.
All right, thanks.
So there could also be the scenario wherein you could be having multiple geographic-based data clusters, index clusters, and you know what I'm calling as transactional systems running against each of these respective countries. And then you have this big monolithic analytical database that's running globally across other data centers. And you could be having replications kind of like established towards the right? And then and all of them happening in real time.
But in that case, your analytic is probably going to just take a very
Have you had any such use cases, like customer use cases?
except that because we have workload isolation, so you know that you can customize your cluster. You could have some cluster that working on the query workload, and similarly, you could have just one work on the analytic workload, and that can basically take the data from all this cluster and run analytic queries across all this. Across the full data set.
And then the true bidirectional active is about updates going down to the same bucket, and then the transactions, the docs, kind of like getting merged and synchronized across all the buckets. That's the true state of like bidirectional.
Yes. Yes.
There was an example of some people had used what she had projected was about different buckets trying to get synchronized. The real requirement is about like
What I had projected was like different clusters. I just abstracted it. But if your question is about,
yeah, and I think someone from the audience who kind of like referring on to the requirement is more like if I have the same like demo and demo out here or beers and beers out here, then how the docs that are getting written out to the
correct.
could actually like be synchronized.
Oh, okay. For the conflict resolution, yeah, yeah. That is the real bidirectional active. Correct. Makes
That's
sense.
where the conflict resolution actually.
Circumstance, yeah. Here I did it later to showcase for both the way, yeah. But I agree with you.
Also, that is a different use case.
Yeah.
Then this is the
The actual use case when it is concurrently mutated from both the ends. Yeah.
And then you could have these to kind of like run back into your analytic.
Yeah, you can definitely. I think someone else had.
Hi. Sorry. Given an active-active setup and a particular set of data, is there an easy formula or rough formula for us to figure out what would be the network bandwidth consumption we would need for? Obviously, it would depend on how many updates there are, but is there a rough formula we can go through so we're not surprised at the network bandwidth cost at the end of the month? And if we want to optimize for if we want to optimize for the lowest network bandwidth usage to trade off for, I guess, not so immediate consistency across the two cluster, what can we do? I mean, if you don't need to have everything immediately consistent across the two cluster, can we dial and tune down certain settings?
So we have something called network bandwidth optimization and the ability to cap the network bandwidth usage that you want XDCR to use. We introduced that capability, I think, in 5.0 or 5.5, 5.0, I believe, 1 year ago. So you can use network bandwidth optimization capability to actually tune replication to your bandwidth. Some best practices are there on, like, based on what is availability, what is your hardware constraint, how much it should be using, and that can be tuned. I think I can give you like what we have to tune that. Is that what you're asking for, the best practices, right? Like what should be tuned for?
Yeah, I think
So
we
the
can
replication-
I think we can give you an estimate. We don't have it on the website or on our documentation.
Yeah, and I was also about to say that it depends upon the speed that you need, right? If you provide this bandwidth and you say with this bandwidth we can say what will be the performance, or if you say this is the performance we need, we can say like what is the network bandwidth that you provide, what we would need to this performance. So it is interchangeable in that aspect. If you know that this is your KPIs, we can give you a rough estimate on what might be the bandwidth consumption. Yeah.
So, if a document is frequently updated in an active-active setup, so does the XDCR happen for every update, or is it batched across multiple updates between data centers?
Every update that is happening, is it batched or is it sent? No, I think it is sent asynchronously. It is sent to
every single update.
Every single update is sent to the every cluster. Like, I mean, depending upon again the interval of the checkpointing interval that we choose.
Yeah,
and
so there are two levels actually. For XDCR, right? I mean, I don't know whether you are familiar with our DCP technology, which is basically our core replication protocol, and XDCR basically is built on top of it. And there's some actually deduping happen in the DCP. So let's say that you have a lot of let's say that you have the same documents, and if you're mutating it, I don't know. I mean, a lot of times within let's say that you mutate about 100 times, right, within a very short amount of time. So internally, the DCP could, instead of actually sending 100 mutations, is actually could condense it into just sending the final mutation, because it tries to conserve processing CPU as well as the network. So in this case, right, you're going to actually send out only the last mutation if you actually modify on the same document. But for example, now you say that I'm going to mutate it over these 100 documents over, say, 30 minutes. Then deduping most likely is not going to kick in. Then we'll basically replicate this 100 document as it is. And when we replicate each document of each mutations, we'll do the conflict resolution. So XDCR does happen on every single mutation, but it will basically subject to any deduplications that will happen in DCP.
So the deduplication is at the data level, service level, and what we extract out of data service is for the replication, where we do it on every update.
Okay.
No, it's not batching. It's basically is instantaneous. Well, we are batching it for sending, but basically is that, for example, if you don't have, so if you have a high volumes come in, right? So we basically batch it to basically to make better use of the network. But let's say that if you are not mutating very heavily, right? So sometimes we don't wait until you get to the batch side because you just don't have. We don't have the you don't just have the volume. So we basically in this case we're just basically going to replicate as soon as possible. No, it's instant. Yeah.
It's only replicate. The interval was for checkpointing, which is like for how many checkpoints you would want in that replication.
That's why the replication latency is actually within Couchbase itself is actually very low. I mean, most of the when you look at replication, most of the cost is actually the network delay over WAN. So we basically replicate as soon as possible.
And one last question. So does the replication involve doing it at each document level, or a bucket that is compressed in your own native protocol?
So we don't compress. That's why I say, right, we want to minimize, because this is a HA solutions, we want to minimize the latency as soon as possible because you don't know when the cluster could go down. So we try to replicate to the other data center as fast as possible. So as long as the mutations come into your data surface, we put in the memory queue, and we basically replicate from that memory queue right away. So we don't wait for at the document level. But just as we mentioned before, right, I mean, if you have a high volumes of data, we basically will batch it so that we send things in a batch to also optimize in terms of the network.
It'd be great if you guys could also do it at the cross-section of a document. So rather than sending a document, because sometimes in certain data models, the document is like pretty large.
Yeah.
And document, as you know, could also contain media.
Yeah.
Right? So there is no point of like moving that media
This,
over.
we understand. There's something in our roadmap, yes.
Yeah.
Yeah.
Thank you.
Okay, thank you all. It was a very interactive session. Thank you. I hope it was helpful to you. See you. Enjoy the rest of the day.